Welcome to SDL2 on Xcode tutorial. In this episode, we are going to do animation. An animation is a series of images rendered one after another. Let's take this dinosaur as an example. You can see that there are 10 images for the walking animation. When we try to do walking animation, we just need to draw this image one after another. And when we go to the end, we will go back to the first image and then start over. So by doing this quick navigation, you can already see a rough animation. Let me look at another example. In this firework.png file, we have a lot of subimages. So to do the animation for the firework, we need to cut this big image to smaller images and then draw these smaller images one after another to animate the firework. These are the typical two kinds of scenarios we will encounter. The first one will have separate images for the animation. The other one has one large image which contains a lot of sub-image for the animation. Now, to understand the animation, there is another important concept called frame. Let's go to the game engine and look at the game loop. Within this game loop, you can see a few changes here. Now, we introduce a new public member for the game engine called FPS. It stands for frames per second. By default, it is set to 60, meaning that we would like to have 60 frames per second. 1 second is 1,000 milliseconds. We use 1,000 over the frame per second to calculate the time for one frame. So we use it as frame time. And then in the highlighted code here, that's the original code. This is actually one iteration within this endless loop. We usually call this one loop a frame. And we would like to make sure that one frame will have roughly the frame time. So to do so, we use the getText and also the delay function. First of all, at the beginning of the loop, we use the getText SDL getText function to get a relative time point, call it frame start. After the iteration, we would like to use the getText again, and then minus the frame start. That will give us the frame runtime. That will calculate the time for this loop. If the loop time is less than the desired frame time, then we need to delay a little bit to make sure that one frame takes up frame time. That's how we ensure that in 1 second there are roughly 60 frames. Now, given that, let's go to the definition of animation. In the definition of animation, you can see that there's a lot of members, but let's jump to the private member first. An animation is a series of images. We encapsulate all these images in one texture. So here, we need to have some function to load multiple images together. That's how we do so in this load function. You remember that last time we know how to load one image using the image path. We have another two load function, handle the two scenarios we mentioned before. The first one is that when we're given a list of image paths, just like a dinosaur, then we will use this function to load all the images for this animation. If we have one big image, just like the firework example, we will use this load function that has a image path and a given list of rectangle to define the subimage for the animation. Let's look at how these functions are implemented. The first load function is actually easier because we have already implemented a private function called load image. What this load image does is to load one image from the path. All we need to do in this case is to look over all the paths and then load the image into the texture, then put it into our sprite sheet. That's it. What is harder is the image when having all the sub-images. First of all, we need to use the load image function to load this image as before. Then we need to cut this big image into smaller images based on this input, res. To do so, we need to introduce some new function. The first one is called SDL create texture. This one we create a empty texture with the given width and height. Also, you can see that the format is RGBA, meaning that the image we have is has 4 channel RGBA. And here, the most important flag is that we need to set the flag to be SDL texture as a target. You can see here that this flag allows us to set the texture as the render target. So you can see here, we set the render target of our renderer to this texture. So whatever render operation to the renderer will be finally redirected to this texture. That's the reason why we have to put the SDL texture as a target flag for the creation of this texture. Next, we just simply use the SDL render copy function to copy into this renderer the original image, but we do not copy the whole image. We just copy the given region here using the rectangle given. And then we render. So because we have already set the render target to be the texture, when we do the render copy operation, it will be redirected to the texture. So now we get a texture with the desired subimage, and then we put this subimage inside our spreadsheet. After we finish doing the loading, remember to set the render target back to the window. You can see, look at the parameter. If we set the texture to be null, that will set it back to the default render target, which is the window. So that's how we load image or sub-image within one big image. Let's go back to the animation. Next, the loop type. There are 2 types of animation. There's one that will loop forever, and there's another one that will loop only certain amounts of time. Let's look at the result of this episode and see these 2 types of animation. So you can see that here the firework has already disappeared. It's the second time when the animation takes a certain amount of time. You can see another animation here. This walking dinosaur will walk forever here. So that is the loop time infinity type. For the firework, it is the loop type lifespan. We use the M duration to control the amounts of frames for the whole set of images. For example, we have 10 images for the walking dinosaur. If one image takes up 3 frames, then the duration will be 30. So that's how we control the animation. Next, the lifespan. So this lifespan is useful when you set the loop type to be loop time lifespan. So mFrame is the internal counter for the animation. It will control which image we should draw on the window. Next, here these are the parameters to control where we should put the animation on the window. For this one, sometimes we might want to scale our animation. So that is the parameter to control the scaling factor. Finally, the depth parameter is to indicate whether or not the animation is finished. Let's look at some code of the animation. So there are 2 important functions here. One is the update function, the other one is the render function. Let's look at the render function first. The render function will take in 2 arguments, the change in X direction and the change in the Y direction. So that's how we change the position of the animation. Next, so this part of code is to control the internal counter of the animation. This frame, you can see that it will wrap around the duration. So if it equals to the duration, it will be reset to 0. Now, if the animation type is loop type lifespan, we need to decrease the lifespan after one update until we reach 0. Then we set the animation dead. That's quite simple for the update. And also for the render, it's not too complicated. First of all, we will get the number of texture or the number of image within this animation. And then we compute the index using the internal counter frame. That will give us the correct index or the correct image to draw. So that's how we get the correct image. Next, this piece of code is to compute the scaling and also the position on the window we should draw the animation. And finally, we will copy to the renderer this original texture on the desired position dictated by the crop and also the rectangle. So that's how we do animation and how we render a animation. Let's look at the code for the tutorial today. Today we have episode 6. You can see that in episode 6, we inherit from the game engine and overrides 3 functions: the init function, render, and the update. In the init function, we are going to load the images we needed for the animation, and then also we need to initialize our animation. In the render function, we are going to render the animation we have. Finally, the update function is to update the animation so that we can have a true animation. Let's look at the code. In the init function, we are going to call the parents init function first to create the window. And then there was 2 types of animation. The first time, here, you can see that we have the first one that we need to put in a vector of image path. We do so because we use the spline function because the file name are in pattern like this. So we can easily make all these names using the spline function. Next, we load the texture using the load function. Remember that the load function takes 2 arguments. The first one is the game engine, and the other one, in this case, is a vector of paths to the images. So we have this as the game engine, and then path is from here, constructing using the spline function. And there's another part, or there's another kind called the load function with only 1 image but a given vectors or region. To do so, we create a rectangle based on the pattern here. We know that each subimage is of 256 by 256. There are 6 images in 1 row, and there are 5 rows. You can see that we have, back to our code here, we have 5 rows and 6 columns. So that's how we compute the region. And we load this image into the firework texture using this load function. This time, we are going to use this load function. You can see that we load multiple texture from a spreadsheet and a list of given regions. So the spreadsheet is inside this image, and here is the given set of regions. Now, let's see how to initialize the animation. To initialize the animation, we are going to use the init function. The first argument is the texture for this animation. In this case, we are going to use the dinosaur. And then the loop type. For the dinosaur, we will set it to be loop type infinity. And we set it to be 60. Remember that we have 10 images for the walking dinosaur. That means we have 6 frames for one image. And then here, if you look at this firework, we init using the firework texture, and we set it using the loop type lifespan. And most importantly, we set the duration to be 90. By default, if we don't specify the lifespan, the duration will be used as our lifespan. Moreover, you can see that we set the position to the center of the window. Now that's how we initialize the animation. Next, to render the animation is quite simple. We just need to use the render function for the animation and put in the renderer. And that's how we do it. Next, for the update function is equally simple. All we need to do is to call the update function for each animation, and that's it. So when we encapsulate all things in one class, code becomes cleaner. You can see that in the render function, we don't have to draw these two animations separately. We just, or manually. All we need to do is to call the member function render. That's enough. And all the heavy lifting is done in this game engine class animation. So that's it for the animation. Thank you for watching.